Gargantuan waves in Earth's mantle may make continents rise, according to what a new study has found. Dramatic cliffs and high plateaus are caused by the same wave triggering in Earth's middle layer when continents pull apart, a new study finds. High plateaus rise in the interior of continents thanks to churning deep inside Earth, hundreds of miles from where they eventually spring up, the new research suggests. As continents break up, massive cliff walls may rise near the boundaries where the crust is pulling apart. That breakup sets off a wave in Earth's middle layer, the mantle, that slowly rolls inward over tens of millions of years, fueling the rise of plateaus, a new study found. Scientists have long known that continental rifts triggered the rise of massive escarpments like the cliff walls that separate the East African Rift Valley from the Ethiopian Plateau, said lead author Thomas Gernon, the geoscientist at the University of Southampton, the UK. And these steep cliffs sometimes fringe inland plateaus that rise from the strong, stable cores of continents known as cratons. But because these two landscape features usually form tens of millions up to 100 million years apart, many scientists thought the different formations were driven by different processes, Gernon told Live Science in an email. In the new study published August 7 in the journal Nature, Gernon and colleagues studied 3 iconic coastal escarpments that formed during the breakup of Earth's last supercontinent, Gondwana. One along India's coast fringes the Western Ghats for about 1,200 miles. Another in Brazil rings the highland plateau for about 1,900 miles. And the Great Escarpment of South Africa encircles the Central Plateau and spans a staggering 3,700 miles, according to the study. The interior plateaus in these regions can raise a kilometer or more, Gernon said. The team used topographic maps to show the escarpments aligned with the continental boundaries, which suggested that rifting created them. Computer simulations showed that the continental rifts disturb the mantle, triggering deep waves that roll inward towards the continent's heart. Next, they analyzed existing mineral data to show that uplift and erosion on the plateau migrated inland at roughly the same time and speed as the mantle wave churned miles below. This showed the two landscape features were likely triggered by the same continental breakup process. In the case of the 3 escarpments in the current study, the churn was achingly slow, progressing at just 9 to 7 inches every million years, the study found. Yet this slow-motion mantle wave dramatically reshaped the landscape. As it marched inward, it progressively peeled off the strong roots that anchor continents at the crust-mantle boundary. Without these anchors, the cratons became more buoyant and therefore rose. Wind and rain over the eons then whittled them away further, making them lighter and more buoyant still. This process culminated in the stable, high plateaus we see today. In theory, the same process may explain other escarpment plateau regions, such as one in North and South Carolina or one south of Cameroon, Gernon said. The cliffs and plateaus in the Carolinas are less dramatic than the 3 studied in the paper, likely because they formed up to 100 million years earlier than the 3 Gernon's team examined. That gave erosion tens of millions of years to erase traces of both mantle churn and uplift. Escarpments from much earlier breakup events are unlikely to be preserved in the geologic record, Gernon said, and the same supercontinent breakup and mantle wave is a catalyst for other geological processes, including the eruption of diamonds from Earth's center, Gernon's team previously found. It's fascinating to think that a diamond worn on the engagement ring may be just one of the results of the same geological processes that form some of Earth's most dramatic landforms, Gernon said. This is by Tia Ghost on Live Science. Please leave your comments and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.